Hello, this is Eduardo Suarez. On my previous video, I showed you how to configure iRVision 2D using a raw mounted camera. Today, I'm going to show you how to configure iRVision using a fixed mounted camera. Not surprisingly, the configuration is identical. Here I have my work cell. In this application, we're going to have a part that's going to be fed from a ball feeder. The part is going to be qualified on its peak position in the field of view of the camera, and the peak is going to be always the same with the exception of the orientation. You can see that the part looks like a washer and it has an oval center shape. The orientation here is critical. The vision system will have to be able to detect the orientation and offset the robot accordingly, so the environment tuning always picks the part with the same orientation. At the same time, the robot will place the part always with the same orientation. You can see here that the place position has a pin that's going to have the same shape as the center hole of the part. So there is only one orientation that the part can fit in the place position. Once the part is in position, a gantry system will pick the parts and the robot pick and place cycle will start again. Since this is the same configuration as the previous video, we're going to review quickly all the steps of the configuration, and finally we're going to do a run test. We're going to start with the option package that I have installed. We're going to go to the robot controller, we're going to go to properties, and you can see here that I have the option package iRVision 2D, that is the R685, and also I'm using the robot, the LRmate 200ID 7R. Now we're going to go to the vision here, and we're going to right click and we're going to select enable vision simulation. The next step is going to be configuring installing the camera. So we're going to go to the sensor unit. Just remember from the previous video what we did, we installed the camera on the environment tooling. In this case, it's going to be a fixed mounted camera that I have already there. But the way that you want to install the camera is selecting the sensor unit. We're going to right click, we're going to go to add vision sensor unit, and from here we're going to select add to the camera, and finally CAD library. Once you open the CAD library, we're going to select the camera black and white. So here you're going to see the sensor unit and the camera. If you want to move the camera around, the best way to do that is selecting the sensor unit instead of selecting the camera, because if you just select the camera, you're going to move the camera without moving the sensor. Here we're going to select the camera, we're going to go to properties, and you're going to see that the settings are going to be the focus length that I selected in this case is 25 millimeters, and on the field of view we can make the field of view visible, and you can see that the camera is looking at the peak position for the part. The next thing that we're going to do, we're going to go back to the vision and we're going to select properties, and we're going to connect the camera to the port number 1. So we're going to select the port and we're going to select the camera and we're going to apply. Now we're going to look at the user tool and the user frame. In this application, I have two user tools. The user tool number one is the one where I have the gripper. This is the gripper that's going to pick the part. We can go to properties and we're going to go to the user tool, and you can see that my tool center point is on the center of the gripper where I'm going to pick the part. We can select the part and make the part visible. And you can see where the part is going to be picked on the gripper. Also, I have another user tool that I call the user tool number 9. That is going to be just a pointer, and we're going to use this pointer to teach the user frame. So we're going to leave the pointer here for now. You're going to see that the tool center point is at the end of the pointer. We're going to go now to the user frames, and you're going to see here that we're using the user frame number 1. We're going to open the each pendant. We're going to split the screens, and over here we're going to select the setup frames, and we're going to change from the tool frame to the user frames. And this is the user frame that I'm using. We're going to select the details. I call it the user frame for vision. And the method that we're going to use for teaching the user frame is going to be the 4-point. And this is the method that we always use when we're using the vision system. So what we're going to do, we're going to bring it up the calibration grid. I have already my calibration grid in here that is not visible, so we're going to make it visible. And the calibration grid is on the field of view of the camera. Can you see here? One thing that we're going to do is also, we're going to make the part invisible for now. And we're going to teach the user frame. So the method we're going to use is exactly the same that we used on the previous video for the robot mounted camera. We're going to select the origin point. We're going to move the pointer to that position, and the other way we can do that is just by moving to that. So we're going to select Shift, move to, and you can see that I have the pointer on the origin point. So we're going to select Shift and record, and we have this pointer already done. Now we're going to move the to center point to the X direction point, and again we're going to teach this position with Shift, record. Now we're going to move to the Y direction. This is going to be my point for my Y direction. We're going to teach that point, and the last point is going to be the system origin that is on the center of the calibration grid. And we're going to teach that point too with a Shift, record. And in this way, we have already the user frame set. So now a couple of things. We don't need the pointer anymore. So what we can do, I'm gonna go to select the data. We're gonna go to the position registers, and position register number 1 is my home position. So we're gonna make sure that I'm using the user frame number 0 for my work coordinates, and just cast, I can just move to that position. Now that we have the user tool and the user frame set up, we can go to the vision system. So we're gonna change this one to the environment tooling number 1, that's the gripper. So the next thing is gonna be setting up the vision. We're gonna go to the robot. We're gonna select the Internet Explorer, and on the website, we're gonna select iRVision, and we're gonna go to iRVision Vision Setup. Here you can see that I have already the camera calibration, and also I have the vision process. So we're gonna select the camera calibration, we're gonna go to edit. Over here we can go through all the steps. So the first one is gonna be the camera setup. We're gonna take a snapshot, and we're seeing right now the calibration grid, and we're gonna go through all the steps for the camera setup. So the first one is gonna be the camera. The camera we're using is the SC130EF, and the difference from the previous video is that in here, when we have the option for the robot mounted camera, we're gonna select no, because this is a fixed camera. Then we're gonna select the calibration. It's gonna use the grid pattern calibration, and we can go to the next step. That's gonna be the calibration setup. Here we're gonna have the application frame. We're gonna select the user frame number 1. The grid spacing is gonna be 50 millimeters for this calibration grid. And this is a robot health calibration grid. We're gonna select no. And the setting grid, the setting for calibration grid position method is gonna be the user frame. We're gonna go to the next step, calibration grid location. For the calibration grid frame, we're gonna select again the user frame number 1. We're gonna press set, and when we press set, I'm not gonna override this one, so I'm gonna cancel in this case. But you're gonna have all the points, and you're gonna have the position of the calibration grid relative to the application user frame. That in our case, the user frame is in the same position of the calibration grid, and that's the reason we have all zeros in here. We're gonna select calibration. The number of planes that we're gonna select is only 1. The projection is gonna be perspective. And for the camera distance, in this particular case, I'm selecting override standoff distance. The reason I'm using that is because if I use the focal distance and I'll select 25 millimeters, my standoff distance is a little different. So in this case, I want to use the override standoff distance, and in here we need to set the distance from the calibration grid to the camera. So in order to do that, we're going to select we're going to go back to the work cell. We're going to select the measurement tool, and we're going to select from, and we're going to select the calibration grid. here, and we're gonna go to the camera lens, and you can see here that it's approximately 886 millimeters. So you just take this distance, and we'll go back in here. We put the standoff distance here, and we find the first plane. We're gonna select in here the window, and we're gonna put the control points in such a way that we select all the possible points in the calibration grid, and we select OK. I'm not gonna do that. And the next is gonna be the calibration points, and here is gonna be give you all the points that is found on the calibration grid. And finally, calibration result is going to be this one in here. The focal distance, you can see this 25.4 instead of the 25 millimeters that I have on the properties for the camera. And you're going to see here that the position of the camera relative to the calibration grid is going to be with this offset, and the position of the calibration grid relative to the application user frame, it has a 0 offset. We're going to save, and with this we ended up with we finished the camera calibration, and we can end the edit. Now we can go to the vision process tool. We're going to edit that, and over here again I'm going to go very quickly with all the steps of the configurations. This is exactly the same as the previous video for the robot mounted camera. We're going to select the parent tool, and here we're going to go to the camera. It's going to be the vision part, that's the calibration that we did before. The number of parts to find is going to be 1, and in here we need to select the part. So we're going to go back to the work cell, and we don't need the calibration grid anymore. We can make the calibration grid invisible, and we're going to bring back the part. So here we have the part again, and I place the part on the same surface as the calibration grid. So we're going to go back in here. We're going to take a snapshot. We found the part, and the next is going to be the offset node. It's going to be the fixed frame offset. The offset frame is going to be the user frame, and we're going to select the user frame number 1. We're going to skip all these setups, and we're going to go to the child tool for the snap tool. Over here, we're going to select the snap window. In this case, we're going to select all the area, but if you want, you can start closing up this area from the moment you are teaching, and when you finish with the teaching, you can open this one up again. We're not going to change the resolution reduction, and we're not going to make any changes over here. We're going to select the GPM, and we can teach the GPM. In this case, the part is already taught, but if you want to do that, just go back to teach, and you can redo that. I'm going to cancel this one for now. And you can see here the training stability, and this is giving us a green on the location and on the scale. and on the angle is not quite green, so the angle is a little critical in here. Training mask, in your case, when you have your real application, you might have to enable the training mask and mask out any glare or any parts that you don't want to see, any shadows probably that you might have from the light system that you're using. Emphasis area, we can edit this one, and in our case the emphasis area would be the oval shape over here. So if you want, you can just select this one and press OK. The set orientation, I think we are good in this case. We are right in the center. Model ID is going to be 1. And here we can set the threshold, the contrast threshold, the area overlap, the elasticity. I'm not going to make any changes to that. And on the degree of freedom, we're going to select the orientation. We can go from -180 to +180. In this case, the part is symmetrical, so when we rotate it 180 degrees, it's going to be exactly the same. We're going to select the scale from 90 to 110%, and the aspect from 90 to 100%. And finally, we have the offset data calculation. We're going to select statics, and the part Z high is going to be 0 because the part is on the same surface as the calibration grid. When we press set, it's going to give us the result, and in this case it's telling us that it's going to give us the reference on X, the Y, and the rotation. And you can see here that it's considering the rotation as 90 degrees. So with this, we are done in here. We can save it and we can end the editing. Once we're done with the vision calibration and the vision process, we're going to go back to the work cell and we're going to create a DP program. Notice that in the case of the robot mounted camera, we needed to have a program to move the camera to the vision position in order to train the part. Since this is a fixed mounted camera, we don't need to do that. We're going to open the test pendant and we're going to select the pick part program. You're going to see here that we changed to the user frame number 1. Then we're going to use the instruction vision run file. We're going to use the instruction vision get offset, and we're going to put the offset on vision register number 1. Also, we have a jump label that in case that something goes wrong with the vision system, we can jump to this label. And then the only thing that we need to do, we need to just set a position. That's going to be our approach position with the tool offset from a position register number 2. That's going to be just a Z offset plus the vision offset from vision register number 1. Then we're going to go to the peak position, and here I have a call for the simulation. I have a wait of 500 milliseconds and then go back to the retract position. So now at this point, what we need to do, we need to teach the point number 1. So we're going to bring the robot to that position. And we need to do that with the same orientation that we have of the reference model. So without moving the part from the reference model that we have, what we're going to do, we're going to move the robot to that position. And what I'm going to do is assign, we're going to make a close view, and we're going to bring the robot on that position there. So this is going to be our position. That's where we're going to teach the part. It's going to be closer over there. So we're very close. And we're going to go back to the teach pendant. We're going to make sure that we have the tool selected number 1, and we have the user frame number 1. And then we need to just teach the position with a shift touch up without considering the offset from the vision register number 1. So we need to take this one off before we can teach that positioning there. As you can see so far, this part of the program is exactly the same as what we did for the robot mounted camera. Next, we need to go back and select the place part program. This program is very simple. We have 3 positions: an approach position, a place position, and a retract position. And on the middle, just I'm calling the simulation program and waiting for 500 milliseconds. So we're gonna move the robot to the first place position. It's gonna be this one over here. We are very close. It's over there. And we need to place the part in the same orientation as we need for all the other parts. So this orientation is going to be without any rotation. We're going to bring back the program. Now, in this case, we need to make sure that we're using the tool number 1 and the user frame is going to be 0. We're going to be using the world coordinates, and the reason for that is because we have the robot mounted on the table and we have the place part also on the table. So if the table moves, everything moves together. So we're going to go to the place position, and in this case we should have to remove the offset that we have in here, and at this point we just press shift and touch up, and the offset that we're adding in the all the positions and the approach position, the place position, and the retract position is as a table offset that is going to be offset that we're going to see in a moment how this all works. Finally, we're going to go to the main program. We're going to select the main program in here, and from the main program, what are we doing? We are just setting the user frame, the user tool. We're going to go to the composition, and from there we're going to call the initialize. That's going to initialize the position register for the table offset. We're going to create 2 loops. These 2 loops are going to index the place position from the row, and the column in here. So we're gonna index on the X and Y. We're gonna call the pickbar program. Then we're gonna just change the user frame to the world coordinates, and we're gonna go back to home, and we're gonna call the place program. And we're gonna continue looping until we end up with all the parts on the table. So now we are ready to test the program. We're going to go back to the beginning of the main program. And what we're going to do for now, we're going to just go step by step. And we're going to run this program just on step mode to make sure that the program works as I will need to make it work. So we're going to just step forward. We're going to go to the home position. We are in the home position right now. We're going to start the loop. We're going to call the pickbar. We change the user frame. We call the vision. We're going to get the offset. And what we can do, we can look at the offset in here. We're going to select the vision register, and we're going to select the vision register number 1. So in here you can see that, just give me a moment. We got the offset. And the robot goes to the approach position and the peak position over there. We go back to the retract position, and now we're going to go to place a part. And this is the position where we're going to place a part. So you can notice in here that if we look as a reference, this bracket in here, this is a bracket we're going to use for all the dressing up the air hoses and the sensor for the gripper. This bracket is going to be always in the same orientation because we're placing the part always in the same orientation. So we can see that this program works. We can go back to home. And we're going to do now, we're going to change the orientation of the part. So we're going to go back to the table. We're going to select the part in here. And we're going to change this orientation. And we're going to move it to something like minus 52 degrees. You can see now the part is rotated. We're going to run the program again. We're going to get the vision offset. So you can see now that the orientation changes, and also it changed the offset on the X and the Y. And now we're going to see if the robot goes to pick the part in the right location. You can see now that the brackets have moved because we moved the part more like more than 50 degrees, and we are in the same position with a different orientation. So the vision system works. We can continue the program, and now we're going to go to place. And we're placing in the second position with the same orientation that we need for each one of the parts. We're going to go back to home, and what we can do now, I'm going to abort the program. We're going to go back to the beginning. We're going to change this one over here, and what I'm going to do, now go back to the part and make sure that we have on the simulation, we're going to generate the position randomly, and we're going to change is the rotation. We're going to move the rotation on the plus and minus 90 degrees. We're going to select OK, and we're going to run the simulation and see how this one works. I'm going to bring back the pitch panel so we can see here the offset. We can see that the offset changed. On the next part, the offset changed again. So it keeps rotating the part randomly. You can see that the bracket for the grip position also changed orientation. So the vision system is able to accommodate for the orientation of the part and is able to place the part in the right orientation always. The last two parts. The last part, and the robot is going to go back to home, and it's going to wait for the entry system to pick up all the parts from the table, and then the cycle is going to start again. In conclusion, the process for configuring iRVision 2D with a fixed mounted camera is in essence the same as the configuration for the robot mounted camera. In the previous video, we were not interested in the part orientation. In this application, however, the part orientation is critical, and the vision system is able to detect and give the correct offset when there is a variation in the orientation for the part. So with this, I'm going to conclude the presentation for this video. I'm going to leave the link to the work cell on the description below.